Here's the shift almost nobody wants to talk about. The AI story isn't just about smarter models anymore. It's about power plants, supply chains, and who controls the rails. If you felt the hype cooling, you're not imagining it. The mood in boardrooms has moved from try everything to show me the margins. Let's ground this in a human moment. Picture a CIO staring at two numbers. On one side, the innovation roadmap. On the other, a swelling bill for GPUs, electricity, and compliance. That's when priorities change. Not because AI stopped working, but because the costs and constraints got very real. So what actually shifted? Recent reports from analysts and operators point to a few clear moves. Cloud giants, those hyperscalers, are rethinking where they build data centers. Model platforms are tightening prices and going deeper into enterprise partnerships. Chip makers are redesigning around geopolitics, not just physics. And telecoms are betting big on AI-native networks to escape commodity margins. We'll unpack what that means in plain English. But first, here's the headline. This looks like the start of AI's industrial era. Less moonshot, more grid connection. Less, can we? More, who pays, who profits, and who controls the bottlenecks. Now, why now? A few forces collided. The energy footprint of AI is spiking. Grid capacity in the biggest hubs is tight. Regulators want safety, data sovereignty, and resilience. And the easy growth from free or cheap experimentation has matured. That pushes leaders toward discipline. Fewer freebies, more bundled contracts, more enterprise grade. Let that sink in for a second. The value in AI is shifting from the flashy demo to the boring plumbing that makes it work at scale. Here's what that looked like in recent weeks. Hyperscalers started prioritizing power above everything. This is called power-first site selection. Instead of building where talent or tax breaks look great, they're building where electricity is available fast and at scale. Think Tier 2 markets that can hook you to power 12 to 24 months sooner, with cheaper land and fewer grid bottlenecks. In other words, the new cloud strategy starts with the substation, not the skyline. At the same time, AI platforms are becoming less generous with usage. Prices and rate limits are creeping up. More of the action is in enterprise bundles, legal protections, data controls, and integrations into the software businesses already use. This sounds dry, but it's where the money is, and it's where regulators spend their time. Now pause. Here's what actually matters here. The bottleneck has moved. It's not just about training the biggest model, it's about delivering predictable performance. With compliant data, on infrastructure you can actually power. Let's slow that down and explain the mechanics. First, power-first site selection. Imagine you're building a factory that guzzles electricity. You can go where the industry always goes, or you can go where the grid says yes, quickly. Hyperscalers are choosing the latter. They're partnering with utilities, lining up long-term power deals, and even exploring future sources like small modular reactors or fusion partnerships. Those experimental options won't flip on tomorrow, but the intent is clear. Control the energy if you want to control the compute. There's a hardware side too. AI racks run hot. Many now use liquid cooling because air just isn't enough. That shapes where you can retrofit existing buildings versus where you need a greenfield site designed for heavy racks, dense cooling loops, and water reuse. Second, the AI stack is industrializing. Model capability is converging, so platforms are differentiating at 3 layers. Proprietary data and fine-tuning, unique datasets and training tricks that matter to a specific business or sector. Distribution and integration. Building deep links into SaaS tools, sector clouds, and workflows people already live in. Compliance tooling, audit logs, regional data controls, and governance features that pass an industry's risk test. In other words, the moat is shifting from pure model prowess to the rails and rules that wrap the model. Third, chips. For years, the race was to the next process node, smaller and faster transistors. That's still important, but physics and geopolitics now share the driver's seat. Enter advanced packaging and chiplets. Think of chiplets like Lego bricks for chips. You can mix components from different manufacturing nodes and even different suppliers, then connect them with super fast links in a single package. Why does that matter? It boosts performance and power efficiency for AI accelerators without relying only on the absolute bleeding edge. It also spreads supply risk. If one region hiccups, you can still ship a product by reconfiguring the mix. Finally, telecom. Networks are getting AI native. You'll hear 2 phrases a lot, AIOps and network slicing. AIOps means using AI to automate operations, predict outages, tune resources, cut costs. Network slicing creates virtual lanes on the same physical network, each with its own guarantees, like low latency for a factory robot or high reliability for a hospital device. Here's the thing, telecoms want to stop being just pipes. If they can prove these AI-driven guarantees for edge computing, putting compute near devices, they can sell outcomes, not just gigabytes. Let's take a breath and connect the dots. Hyperscalers are turning into energy strategists because AI is a power business. AI platforms are monetizing like enterprise software because compliance and integration are where customers feel pain. Chip makers are diversifying and modularizing because the supply chain is the battlefield. Telecoms are automating and slicing because they want platform margins, not utility margins. So who feels the impact? Enterprises will likely see clearer roadmaps and stronger service agreements, but at higher, more predictable costs. The era of open-ended, low-cost AI experimentation is fading. You'll be nudged toward fewer, more integrated platforms that bundle compute, tooling, and legal protections. It's a trade. Less flexibility, more reliability. Developers and startups may feel the squeeze on generic wrappers around large models. The good news is, there's room for specialized tools, especially where you can tie into real workflows, proprietary data, or regulated use cases. The bar is just higher. Hardware buyers, CIOs, CTOs, procurement leads, get more supply resilience over time, but also more complexity. Regional fabs, export controls, and diverging regulations mean you're managing a portfolio, not a single SKU. Standards for chiplets could help. For now, it's more spreadsheets. Telecom customers, manufacturers, logistics, healthcare stand to gain from lower latency, more dependable networks that actually meet service-level promises. The open question is, who captures the value? Carriers, cloud partners, or the platforms sitting above both? Now, the uncomfortable parts. Energy constraints are real. Grid interconnects can take years. Retrofitting water and electric capacity into new regions is hard. And while nuclear or fusion partnerships get headlines, they won't bail out near-term capacity on their own. That's a risk for anyone betting on rapid AI scaling. Dependency risk shifts, not disappears. A telecom that leans heavily on a hyperscaler's edge stack reduces one form of vendor lock-in and introduces another. The same goes for enterprises that standardize on a single AI platform for compliance and distribution. It simplifies today and concentrates power tomorrow, and regulation is still catching up. Safety rules, data localization, and infrastructure security are evolving. Players with deep pockets can build compliant stacks and navigate audits. Smaller vendors may struggle, which accelerates consolidation. So, where does this go in 2026? Watch for rails and rules to harden into moats. The rails are compute, chips, networks, energy. The rules are governance, localization, and industry controls. The winners combine both. Expect hyperscalers to look more like energy companies, signing long-term power deals, building near substations, and using heat reuse and liquid cooling as design norms. Expect chip portfolios to get more modular, with chiplet standards gaining attention. Expect network SLAs, those explicit performance guarantees, to become the language of edge applications. Let's slow down for a digest moment. If you remember one idea, make it this. The center of gravity has moved from demos to delivery. The biggest fights will be over bottlenecks, power, packaging, spectrum, and compliant data, because that's where margins hide. A few practical takeaways if this touches your work. If you manage AI budgets, model the full cost, not just tokens or GPUs, but power, cooling, compliance, and integration. In other words, the total landed cost of a use case. If you're picking platforms, kick the tires on governance. Ask how they handle audit logs, regional data residency, and indemnity. The legal plumbing is now a feature. If you build products, lean into proprietary data and workflow integration. Thin wrappers are fragile. Specific measurable outcomes travel better. If you buy hardware, plan for multi-region sourcing. Track packaging roadmaps and chiplet interoperability. Optionality beats hero chips when supply gets bumpy. If you run networks or edge deployments, measure before and after with AI ops and slicing. The business case lives in hard numbers: uptime, latency, energy per workload. And if you handle strategy, watch energy deals, not just model benchmarks. Where the megawatts go tells you where the platforms are headed. You might be wondering, is the AI hype actually over? Not exactly. The story just matured. Think of it like commercial aviation. The golden age headlines were about the first flights and fastest jets. The real industry power came later. route rights, gates, fuel contracts, and safety standards. That's where we're headed with AI, chips, and telecom. One more grounding point. Industry estimates suggest data center power tied to AI could roughly triple by the end of the decade, comparable to the needs of a very large US state. That scale forces choices. Build where the grid says yes, package chips in modular ways, automate networks so costs don't spiral, and price AI like a serious enterprise product, not a demo. Here's the quiet implication. In an era of engineered scarcity, compute, spectrum, compliant data, the leverage goes to whoever orchestrates the constraints. That's why you're seeing power-first builds, chiplet portfolios, AI-native networks, and enterprise-heavy AI bundles. They're not hype killers, they're hype translators, turning excitement into durable infrastructure and cash flows. So if you're exploring this space, it can help to think less in features and more in contracts, less in demos, more in delivery guarantees, less in sprints, more in power purchase agreements, multi-year chip supply, and compliance roadmaps. It's not glamorous. It's how big technology becomes reliable. Let's wrap with a simple lens you can carry forward. Follow the power. Who's securing megawatts, where, and on what timeline? Follow the packages. Who's mastering chiplets and advanced packaging to ship around bottlenecks? Follow the platforms. Who's bundling AI, data, and compliance into offers enterprises actually trust? Follow the promises. Who's offering network and AI SLAs that a CFO will sign? That's the new scoreboard. Not the most viral demo, the most durable contracts. Thanks for spending time on this. If you found it useful, a like and subscribe helps us keep making these videos.